All right. Okay, guys. We have Alice again. Please. Let's do it.
Thanks very much for coming, everyone. It's really exciting to come to Bristol. I'm going to be telling you about a project which is taking place entirely over the internet. And being someone who destroys technology as soon as I walk near it, I'm the perfect person to be doing this. The project's called Galaxy Zoo, a great big zoo of galaxies. You could almost say it's like ecology, like biology, like studying millions of animals. Because galaxies are all different. There are some species, some types. The story, is that working?
Yes.
Oh, excellent. Don't really want my head to get in the way either. The story began at least 10 years ago with a robotic telescope in New Mexico. It was only quite recently, really, that digital cameras were invented. And all those digital cameras in our mobile phones, but astronomers, of course, were way ahead of the game. They built this robotic telescope, the Sloan Digital Sky Survey, up in the very clear-aired mountains of New Mexico. Apparently there's warm air down the bottom, which comes up to the cliff top and clears the air for it. Over all these years, it's been gradually scanning the sky. It's got 5 different filters. So it can pick things up in many different colour bands. It can pick them up in infrared and in ultraviolet. If anything moves, then it gets picked up at slightly different places. Or rather, if the Earth moves, as it does all the time, while the telescope is watching the object. So anything nearby gets split into different colours. Unfortunately, that doesn't happen with galaxies. The camera's extremely sensitive. It's cooled to minus 80 degrees by liquid nitrogen, and therefore, if it pointed at anything close to us, the optics would be fried immediately, so it can't look at planets or anything like that. There are actually 30 different filters, but it pieces them all together. This is a general map of where it's covered. It's done about a quarter of the sky now, and it's increasing all the time. It's just released a new area that they call Data Release 7. In some places it's had a bit of difficulty finding it, and it's done these swoops at the edges of its vision. If you zoom right into those, it looks a bit like a scarf, like the end of a scarf with the tassels on it. Bits of sky, bits of galaxies which it's picked up, and bits it hasn't. My favourite thing about that picture is that you can see the plough in it. Those aren't photographs of stars, they're actually circles of light that the camera has drawn in, simply to avoid getting its optics fried. But you can still recognise some constellations up there, and that makes it seem really real, even though there's no people manning it. It's just a robot. Zooming in a little bit into the plough, you can see the fuzzy texture of billions of galaxies behind you. Zooming in a bit further, it's picked up something definite that we can see, M51. And a bit further, it shows a lot more detail. And a bit further, it shows so much detail that it doesn't actually dare focus directly on this object. If you try to get the internet picture straight at the galaxy, you have to really force it into it. That galaxy pretends that that telescope pretends that the Whirlpool galaxy doesn't exist simply because it's so near and so bright. It was made for looking a long way away. Now, if you look at it from a 3-dimensional point of view, it can see a very long way, not quite to the cosmic microwave background, and what it can see at the far edges are mostly quasars. And one day, perhaps, all of this would be as if it's a sort of white globe, really, everywhere that it's picked up. Well, I said a minute ago that galaxies are all different. The reason they're all different is because they're all doing something different. In some of them, the stars are all rotating round in a sensible sort of order. In others, the stars are just doing whatever they like, going wherever they like. Now, galaxies have different ages, different quantities of free gas for star formation. And the consequence of that is they're all shaped differently. They all have different colours, all have different size, and therefore we can work out what kind of galaxy it is and why. A few years ago, some of these people in Oxford and Portsmouth universities, and some in America as well, had some projects to do. And Kevin, who is looking away from us in the white shirt, he was a PhD student at Oxford at the time, and he was studying a very strange sort of galaxy. It was called the blue elliptical, and I'll explain what that means a bit later on and why it's so strange. And Kate, who's on the far left, had a quite different problem, and in fact she and her team turned up right at the last minute, even though she and Kevin's PhD supervisor Chris were actually sharing an office. Her project got added to Galaxy Zoo just before it went live. And again, I'll explain a bit more about Kate's project later on. But she was studying spiral galaxies. Kevin's project was the blue ellipticals, slightly on the left. And Kate was studying which way spiral galaxies tend to go round. Now that seems a completely ridiculous question, because they go round whichever way they want. But somebody had spotted spirals doing something a bit peculiar. Well, Kevin had to classify galaxies into spiral and elliptical. He was looking for the elliptical ones, the round ones, the disorganised ones. He did 50,000 in 1 week. And apparently, I don't know if this is true, but Chris says it is, your PhD student will classify 50,000 galaxies before telling you exactly what you can do with the other 850,000 that you have to classify. Because the problem with the Sloan Digital Sky Survey is that it's photographed about 200 million objects. And Chris and Kevin managed to reduce it to 900,000, but that was just too much to be dealing with. You can't have a couple of scientists dealing with 900,000 galaxies. And Kevin does not recommend ever doing the 50,000 again. He said you get very bad headaches from it. And one evening, sitting in the pub, like the good professors they were, Chris came up with an idea. He said, well, there's stardust at home. If people will look at dust grains, then surely they'll look at beautiful galaxies. They thought maybe 3 or 4 years down the line, they might have got a few people interested and a few more galaxies classified for them. So a friend of theirs helped them set up this website. They thought of Galaxy Safari as a name, but decided on Galaxy Zoo. So anyone can join. You don't have to be an astronomer. You need no qualifications, no knowledge or experience. All you have to do is look through a quick tutorial and be able to answer 8 out of 15 questions correctly. It was 10 at first, but they found out that even the inaccurate people actually got much better at it. They found, to their intense surprise, that amateurs were better at the classifying than professionals. Apparently 6-year-olds can pass the tutorial, and apparently a professor of astronomy failed it. The reason for that is that the questions were very simple. You teach the public what a spiral is and what an elliptical is, and a couple of other ones, because of course they're going to creep in, and you let them go from there. Well, the main way to separate spirals and ellipticals is, does it seem to be going round in circles? That is, does it have these spiral arms? And if it's an elliptical, it's just a round or rugby ball-shaped blob with a bright nucleus, usually. And also usually it's yellow, not blue, but not always. And with a spiral, they also wanted to know which way is it going round. With this one, the arms are sort of trailing along behind, so it's going round anti-clockwise. It takes ages to develop an eye for which way it's going round. I had to move the mouse round and round and round in circles to work it out. But eventually you get the